Okay. All right. Can everyone see my screen?
Yes, sir.
Yes, sir.
All right, great. Yeah, talking about modules and packages in Python. Um, and so, as you may know, Python is one of the leading programming languages, especially in data science and science in general, due to the large amount of data science modules and packages. You'll also hear them called libraries. And so these are free of charge, right? People make them and then pretty much upload them where you're able to download them to your machine. There are over 200,000 packages available. That sounds incredible, but it's true. And so we'll be using some of the libraries that you can find in this link right here. So also there's the Python package index, which you can search for packages that are applicable to your project. And so when we talk about modules and packages, what are we talking about? So modular programming refers to breaking up large tasks into separate, smaller subtasks or modules. And so these modules can all be put together and to create a larger application or package or library. And so a module is a file containing definitions and statements that have a specific functionality, and a package is a collection of these different modules. And so essentially the packages are basically a directory format or a folder. If you're more used to that kind of visualization, like in Windows. And so, like I said, the library and package are used interchangeably in Python. And so in Python, we have two types of modules. We have built-in modules that come with Python installation. And then we have user-defined modules that you can install or make yourself. And so one of the advantages of Python is its built-in modules. And so it provides a lot of reusable code that you can use or that people use to make their own custom modules as well. And so some common built-in modules: datetime, OS, which is operating system, math, sys for system, random, creating random numbers. And popular data science packages, NumPy, probably, one of the most popular packages, SciPy, pandas. And so you can click on all of these links and read about them. Matplotlib for plotting, creating graphs. And so pandas is for making arrays, right, large data sets and manipulating them easily and quickly. Scikit-learn, this is your machine learning modules, right? So say we want to do like a regression modeling, we want to predict some outcome, or we want to cluster some data, we would use scikit-learn. TensorFlow, this would be deep learning developed by Google. And then there's the Keras high-level library, which makes it easier to use TensorFlow. And so user-defined modules, we can create our own module. And again, these contain classes, right? What kind of data are we using, functions to manipulate the data, variables. And so to import modules, it's simple import statement. We can import specific classes and functions from a module if we just need to do that. But for example, if we want to import, a package or module, we just do import and then package or module name. And so for built-in modules, we can import them by using this simple code import built-ins. And we can check the built-in modules by using this directory function. And you can see some of the built-in modules that are available. Some common ones that I think are useful for the beginner, sys module, syspath. And so if we want to check where our modules are being searched for, so when we say import a module, it's going to search these specific locations, right? Which is in our environment variable Python path. And so say we made a custom module and we want to add a destination to our module search path. We can do that by doing this. For example, I made a new path or a new folder, new modules. And so whenever I do import, it's going to search this area as well. And OS. And so this is how we interact with our operating system. Some useful tasks for this would be first we import OS, right? And we want to see where our working directory is. We would say os.get current working directory, right? And that's going to print out where exactly I am situated at the moment. And you can also change your directory using that same module, os.change directory. And just showing here that I just changed back to the original. So importing and working with modules. Here we're going to demonstrate pandas. And so I downloaded this CSV file, comma separated values, which is a common, file type for large data sets. And so first we import pandas. And then so we want to create a variable travel data equals pandas dot read CSV, right? So we imported our package pandas, and we're going to use the module read CSV from pandas to import this the CSV file as a data frame. And so we can have a quick look at the data frame to kind of get a quick overview of what's going on, the column names, and what kind of data we're working with this head function. And right here, I'm showing the first 5 rows from this CSV. And so this is called, when we do pandas dot read CSV, this would be considered dot notation, or the travel dot data dot head, where we can call on specific functions within a package. Say I want the first 10 rows instead of just the first 5. I would, instead of putting nothing in the parentheses, I would put 10, and it's going to give me the first 10 rows. And then we can also, from our travel data frame, we can also plot, defining the X and Y axes. Pretty simple to do. And we can switch it up, changing longitude and latitude. And so for NumPy, right, we would import our package NumPy, and to create an array with length 6, we would create a variable a equals NumPy dot arrange 6, right? And so we have an array of length with 6 digits. In a similar fashion, import math, and then so to use the square root function from math, right? We just do math dot square root of 5, and it's gonna, give our result right here. And so if we want to do import multiple modules, we can just separate them by a comma. So import math, import random. And then this is just showing the factorial function of the math module using 5, and generating a random integer from the random module in between 10 and 20. And then, so if we want to only import specific classes or functions from a module, we can do that. So, right, some of these packages or modules are pretty big, and we don't need everything. So we can just, from our math module, import only the factorial function, right? And when we do that, we don't need to call on the math module. We can just say, we can just use the function directly, right? So that makes it a little easier to work with. And so another common thing to do is to rename a module. And then so this is called aliasing. And it just makes it easier, more convenient, right? So import random as rand. And then so we here, this is basically random, right? But we named it as rand. And then so using the rand arrange function, 10, 22. And then from random import rand int as random number, giving it and so yeah, it's just a convenient way to rename some of the functions of modules. And so if we want to import everything, we're not sure what we'll need. So we just want to import everything. We'll just do this little wildcard. And so the asterisk is a wildcard. It's going to say from the math module, import everything that's included. And so I'm not really sure what everything is included, but like this function is included, power, factorial is included, pi, square root. And so you can just call those functions directly from that module. And so in Python, to create a module, it's basically just Python code in a file that with a .py extension. And so this is a little, there we go. This is an example. This module is called the Fibonacci numbers module. And so it has two functions, fib and fib2. And so basically what you would do is go into a text editor. I prefer like Notepad++ for Windows, and save it as fibo.py make sure you're in your current working directory. And so basically, yeah, this little module has these functions that will print the Fibonacci series depending on what number you include. And so to import our new module that we created, we would simply do import Fibo. And so when we do that, this does not add the names of the functions, right? Fib and then fib2 to the namespace. It only adds the module name. And so we can see which names our Fibo module defines. And we can see that our two functions are there. But still we have to use the module name first to access these functions. But if I were to do imports from Fibo import fib, right, like back here. We could call those functions directly. But yeah, see, so Fibo, our module Fibo that we created using the function fib, using 1000, it's going to return write a Fibonacci sequence up to 1000, and then the second one using 100. And so packages, like I said earlier, are basically just directories that contain the modules, and they also contain a special initialization file. And this file tells Python that the directory is a package and it can be imported. And so this is basically, I was trying to draw like a directory structure, but so here's my package. And then these are my modules inside mod1, mod2. Here's that special initialization file that I was talking about. And so if I create two modules, like I did with the previous module in a text editor, and I save them with the .py suffix, and I place them in a folder named package, pkg. I can import them like so. And if I call on them using package.mod1, right, that's my module, and that's my function foo. And so these just print this little message. You know, they'll print the message. And so if we create that initialization file, which basically says, okay, you're going to import these packages or these modules when I import this package, right? And so I say, and that's in that package directory. And so from when I do from package import everything, and then I can just call on module 1 function foo, module 2 function bar, and they will work. And so when you're working with packages, you might see that they kind of go, they have several dot notations. So packages can also have submodules. And so this is a kind of a good illustration of that. So we have our package here called sound, top level package, and with our little special file, right? And then we have our formats sub package, and then we have our modules, our .py modules. And so if I wanted to load what we might call a submodule echo from this effects subpackage, right? I would say from sound, our package, .effects, import echo. And so when you're working with these packages and looking at the manuals, you might see kind of there are several layers to these modules and packages and functions. Okay, and so when you're working with packages, luckily there is a package manager for Python packages. And it should be automatically installed when you install Python. If it's not, you can easily install it as well. But basically you type pip install and then your package, right? And it'll do all this crazy, it'll spit out all this crazy text, like it's checking the dependencies, the versions of everything. But if you just want to get an idea of what it can do, you can just type pip and it'll give you, you know, how to use it, pip commands, and these are the different commands. Most of the time you'll be using install, but there are all these other commands as well. And so let's say I want to I want to install a new package. And so I'm going to go to, kind of hard to see this, but Okay. All right, so I'm gonna go to the pypi.org and I'm gonna say, what am I interested in? Maybe some pharmacophore modeling. And I've never tried this before, but can you guys still see my screen?
Yes.
Okay,
Yes, sir.
so here is the the page for this package PMapper. And this is essentially the way you would install it, and you can just easily copy that to your clipboard. And then it's got a bunch of different information, dependencies, what you'll need to run this package. So something like RDKit, which is a chemistry kind of package. And then there's different examples that you can use as well. And so I go back to the notebook. And so basically pip install PMapper, I just use this little verbose flag to print out. If you use that, it's going to print out everything that's going on in the background. And so I did need to install that RDKit as well. And so I did install that as well. And then so if I just do import PMapper, I'm not going to get all the different modules and functions that I need. So for this specific example, I need to import this function pharmacophore from the pharmacophore module. Right, same with this RDKit. From RDKit, I'm importing chem. From this chem module, importing all chem. And then so, this should work. It does, right? And so this is just from their example from their website. Yeah, and then so basically if it says, successfully installed, you should be good. There are times when you will get errors. You just kind of have to, thankfully, a lot of, the Python errors are pretty informative and you have to kind of read through them and they should tell you what exactly is wrong. And you'll have to fix that. But this was pretty seamless, installed easily, and then, based on their example, it works fine. And so another package manager that is popular is called Conda. And so this offers, the main advantage of this is the environment management. And you can go here to check out Conda. But basically, Conda creates environments, virtual environments that enable you to run programs without interfering with other programs in your machine as well. And so, yeah, one of the main advantages is this environment management system. And so if you go to a lot of these software or websites like on GitHub, usually where a lot of these softwares are maintained and housed, they'll recommend that you set up a specific environment for their program. And so the whole idea is that this prevents clashes between other programs on your machine and their dependencies. So for example, program A will require version 2.0 of some dependency, say like RDKit, like shown previously, while program B, a whole different, software program requires version 2.2 of RDKit. And so if you install one, the later version is going to take precedence and it's going to, your program A is not going to be able to work because you don't have the right version. And so Conda, creating environments with Conda, allows you to deal with that. And so they're also language agnostic. And so they support other languages other than Python, such as, Bash and Perl, all the other like Java. And we can check the available environments And so typically this is done at the terminal or the Anaconda prompt, PowerShell, prompt terminal. If we just do Conda environment list, it'll list all our different environments. So I have some for, PyMol, which is a program for looking at like protein structures. I created one for Leap, but this little asterisk is going to say which one you have currently loaded. And that's always, when you start off, it's going to be your base environment. Like if you want to create a new environment, you just do conda create -n, and that's gonna be your name, and then you can install. Then you would list all the different packages that you need for that environment for that program to run, and you want to install them all at the same time, so there's no issues. And to activate your new environment that you created, it's simply conda activate Leap. And then to deactivate, you just do conda deactivate, and then you're back at your base environment. There's also mini conda, which is a lightweight version of conda, and Mamba, which is a faster version written in C. And those you can check out those too. Yes, does anybody have any questions about packages and modules? I mean, this is really where pretty much anything you can think of, any kind of data analysis or transformations of data, there's probably a package out there for you. Um, um, Dr. Ken, are you there?
I'm there.
Okay. Yeah, did you want to add anything else about the packages? The
Yeah,
modules?
but can you just show them how to do the installation of the packages either from Jupyter Notebook?
Yeah, from Jupyter Notebook, you can
You can search, so you can just show that to them.
yeah. So pip will install your packages. Like I installed this directly from Jupyter Notebook. So if there's, like I said, go to that website, PyPy. I'm not sure what everyone's working on, but say you have some, like you're doing some molecular dynamics simulations, right? There's tons of different packages, um, you know, TensorFlow, right? And so it's basically just pip install in the package name. And yeah, it should work in the Jupyter Notebook. Like I've already installed this, but that should work. And as long as you get that successfully installed, you should be good to go, and then you can just import your package.
I have a question.
Mhm.
When it shows successfully installed and you're asked to restart to use the updated package, how do you go about that?
If you go to kernel and restart, it'll restart your kernel.
Oh, okay, I see. Thank you.
Mhm. Yeah. Any more questions? And is everyone able to, open Anaconda, open the Jupyter Notebook?
Yes.
Yeah, okay. Yeah, I guess, try to install, some of these, packages, and see if it works. It should work. Has anybody successfully installed something?
I did the RD kit one. That worked.
It worked?
Yeah.
Great, okay. And then, yeah, you can, from RDKit, you can import this module chem. Yeah. Yeah, and so the most popular, packages, like said earlier, like NumPy, SciPy, Pandas, Matplotlib. When you can start getting into machine learning and AI, TensorFlow. And the thing about all of these packages and modules is that there's usually somebody online that has gone through it and has a tutorial, how to use it. And so for like TensorFlow, if you're interested in deep learning, right, Google has a whole training, website for TensorFlow and, image classification, or just, neural networks to predict, certain things, text classification, stuff like that. Scikit-learn is really good as well. They have a lot of different, machine learning algorithms, and different examples.
I think someone is asking you a question on the chat.
Somebody's got a problem. I'm at work, not physically at my computer, but what should I do if nothing works? Like I said, with the good thing about Python error messages is they will say exactly kind of in the line of code, or where something went wrong. And so, I mean, from I'm a little more experienced in troubleshooting and debugging, like stuff like that, but another good way is kind of highlighting the error and Googling it. And I'm 100% positive somebody else has encountered some problem like that, and then you can see how they managed it. But I mean, as far as installing packages, there may be some like dependencies that the package you want to install those aren't met, as in you don't have them. I know this is in R, this is very common, where you try to install a package and then it requires some other package, but you have to install that one first, and you kind of go down this rabbit hole. But I mean, that's one thing that I think I'm trying to predict that can go wrong. But usually, the good thing about pip is it's very user friendly, and it usually checks everything, and it works most of the time. No problem. Yeah, so I mean, I'm kind of, I don't really know what everybody's studying. I'm assuming something in pharmaceutical sciences. But like I said, there's so many packages, right? Like over 200,000 packages. That, there's got to be something out there that you can use to help or, you know, your project.
Yeah, thank you so much, Dr. Scott. So do you have
Yeah.
do we have anything you want to add, or if there's any question?
No, sir.
Yeah, and if you know, if you're practicing and you have problems, I kind of enjoy debugging or, you know, fixing things. So you can shoot me an email, and I'll try to help you out.
Thank you so much, Dr. Scott. Thank you so much for that. I'm introducing modules and packages to us. So there are a lot of modules, there are a lot of packages already inbuilt in Python that you just need to know how to install them. Then you import them, like you call them into function anytime you want to use them. So that's great. So yeah, yes. So let's continue from where we stopped last week, because I remember we didn't finish on that. So let's continue from our control flow. Yes, if you remember, how many of us remember? I think because of that, let me do something. Give me 1 second. Let me stop the recording.